Good morning, class. Today is Tuesday, May 12th, excuse me. Let's get started. I'm back in my kitchen again to do math for complicated reasons because my family is packing right now. We're trying to get ready for our move. And this is a pretty complicated problem that we're going to be working through today. But the good news is there's only one of them. So just bear with me, understand what you can. And my main goal of today's video is not that everybody who's solving this video or following along could solve this problem by themselves later. Repeat, my goal is not for you to understand absolutely every aspect of this question. My goal instead is kind of to show you how I work through this problem and to kind of give you some ideas of how not to give up when a particular story problem seems really difficult, how to work through a problem that's really difficult, and how to take something really complicated and take it step by step, because this is not the last time you're going to have a difficult and challenging math problem. So let's get ready for sixth grade together. So with that, I of course forgot to skip past Monday, as usual. Now we're on Tuesday. So our question here says, Candace bought 4 pounds of craft supplies. Maddie bought 7 ounces less than Jacob. Jacob bought 100 grams more than Daniela. Daniela bought twice as much as Candace. At this store, craft supplies cost $18.50 per pound. How much did each of them spend? So our first step in solving any difficult problem is after we read it, we take a deep breath. And this is not just because I'm crazy or really believe in taking deep breaths. It's because it's scientifically shown to give ourselves that peace of mind, to get ourselves to relax, and to tell ourselves, we can do this. So let's write out the second part of the Mrs. Benavides method is to slash the trash. The main trash here is that it's a craft store. We don't really care that it's a craft store. The only thing we care about is that these people are buying supplies for $18.50 per pound and how much of those supplies they bought. The third step in the Mrs. Benavides method is to underline any keywords that we see. So we see a lot of words like less than, which is really important. We see double, which is really important, or twice as much, which means multiply. We see that word $18.50 per pound. Remember, per almost always means multiply. So $18.50 multiplied by the number of pounds. And then the next step 4 in the Mrs. Benavides method, is to underline the question. So how much did each of them spend is what we're really looking for. And a lot of times students, when they see a question like this, will do the following. They'll do all this beautiful work. They'll calculate, they'll convert, they'll figure out how many pounds each person bought. But that isn't what the question is asking me for. The question is asking me, how much did each of them spend, which is a very, very different question than how much did they purchase in pounds. That's an important piece of information, but we need that information to get the final answer. How much did they spend? Okay, so now step 5 in the Mrs. Benavides method. We are going to make a list of all the numbers. So we have, starting here, we have Candace. And Candace, she bought 4 pounds. I'm actually going to pause, write this down, and I'll come back in just a second. Okay, so you see here, I've made a list of all my numbers. I have Candace bought 4 pounds. Maddie bought the same amount as Jacob, minus 7 ounces. And you'll notice I'm starting to write this in a sort of algebra kind of way. This is something you are going to see in middle school, but just take a deep breath. Notice it's just Maddie equals Jacob minus 7 ounces, because that's basically what it is. Jacob is 100 grams more than Daniela. Notice I capitalized more than because it's a keyword that I noticed in my question earlier. Daniela equals 2 times Candace. And again, I'm writing this out in a kind of shorter algebraic formula. Candace times 2 equals Daniela. Daniela has twice as much as Candace. And the last thing, and maybe the most important piece of information, is that this costs $18.50 per pound. Remember, pound can be written as LB. When I see that my final question, and this is why we underline the question, is going to be in pounds, I know that all of my measurements up here need to be converted into pounds. All right, so the 6th step in the Mrs. Benavides method is to see if I can draw a picture. which we can. I love bar diagrams. You know I'm not really a huge fan of Eureka Math, but I will say one thing that I have consistently loved about Eureka Math or any math program that I've used is drawing pictures and bar diagrams. So if there's nothing else you get out of Eureka Math all year, it's that your bar diagrams are your best friend when solving word problems. So the first thing I have is this is Candace, right? Candace equals 4 pounds. I'm still writing the units here because not all my units are the same, and I'm going to need to convert that. So then I'm going to go down to Daniela. So I've accounted for Candace. I'm going to check it off. Now I'm going to go down to Daniela. Daniela has twice as much as Candace. So that's 1 Candace, 2 Candace. So Daniela equals 4 plus 4, which is equal to 8 pounds. So just kind of recapping, how did I get that? Candace, in the problem, it told us she has 4 pounds. Daniela, they told us that she has twice as much as Candace. So that's 4 pounds plus 4 pounds. 8 is twice as much as 4. Okay, now here comes the real interesting part. I'm going to go with Jacob because Jacob's is related to Daniela's. So Jacob has the same amount as Daniela, right? Jacob equals 8, but he also has 100 grams more than Daniela. Now, more than is telling me to plus. So 8 plus 100 grams. Cool. So that means this little piece right here I'm shaving in is the little piece more, that 100 grams more that Jacob has. So how much does Jacob have? Let's figure it out right now. So we know he has 8 pounds. So the really only thing I need to convert here is the 100 grams. A lot of times I'll see students try to add these two first, and that is a big no-no. We want to convert the grams to be pounds so that we're adding 2 units the same together. It's kind of like when we were talking about adding fractions, and I said, you know, if I have a bowl of apples, 4 apples plus 4 oranges, I can't add those 2 together and say that there's 8 apples. I need to change my unit. So if I have 4 apples and 4 oranges, I can change my unit and say there's 8 fruits. That helps me think about it. Hopefully that helps you. So let me set up my proportion and then I'll come back in 1 second. Things that are new to my teaching style include holding a dog so that she doesn't bark while I'm recording. So I set this up here because we know from our song, 28 grams in an ounce, 16 ounces in a pound, 34 ounces in 1 liter, right? So you're heavy, Pug. I can't hold you and teach and sing at the same time. So I set this up 28 grams over an ounce, like a fraction, which is a fancy name. In this case, it's a proportion, which is equal to, and from my question, I knew I had 100 grams. So I want to keep grams with grams, ounces with ounces. So what I'm asking myself now is 28 times what equals 100, okay? This is the part we've gone over like 100 million times. This is the part that gets tricky. When I have something that doesn't fit evenly into this other number, right? There's nothing I can multiply evenly to get to 100. I can guesstimate because I know 4 quarters equals 100, so I know it's going to be a little bit less than 4 ounces. So what I do is I ask myself 28 times what equals 100. So now I need to undo this 28 times. So I flip it. Kind of like how we did our keep it, change it, flip it, fractions can divide. This is like algebra. So instead of 28 times what equals 100, I can now take this number and flip it. I flip the operation. That's all I need to do. So now I have 100 divided by 28, which in problems of this scale, I will let you use a calculator as I did. 100 divided by 28 is equal to 3.57, but I know that this number is correct and I know I'm doing the right process because I used mental math first to guesstimate that this would be a little bit less than 4 pounds. So what I'm going to write in here is 3.57. But wait, this is in ounces. We would like this to be in pounds. So we say 28 grams in an ounce, 16 ounces in a pound, 34 ounces in 1 liter. Customary could be easier. So now we need to change my ounces into pounds, which I'm going to set up in a separate proportion in 1 second. Awesome. So we're still on Jacob, right? We have so far converted the amount of 100 grams into ounces. Now we need to change those ounces into pounds. So I use my song and I set up 16 ounces in a pound, right? Then my next step, which we've gone over 100 million times, is I'm asking myself, 16 times what equals 3 57/100ths? Let's move over to what I was thinking to find out what this answer would be. This is where it gets tricky, remember, just like we talked about yesterday, just we talked about in school, 16 obviously cannot be multiplied evenly to get to 3.57 or 3 57/100ths. Does not work out evenly. And in fact, I know this is getting smaller, so I know that this is going to have to be a decimal or a fraction. So over here, I did 16 times what equals 3 57/100ths, because that's what I pulled from over here. Then I can flip this and make this work for me by going 3 57/100ths divided by 16. Just taking this number, flipped the operation because I'm moving across my equal sign, so it now becomes divide. So when I did that with a calculator, because hard math problems deserve a calculator, this was 22/100ths, or 0 22/100ths. So notice how I kept ounces with ounces and pounds with pounds. My answer is 0 22/100ths pounds. So now I know that Jacob, his total weight equals, in pounds, is 8. And remember, I got that 8 from Daniela because his is 100 grams more than Daniela. 8 22/100ths pounds. All right? So far, Jacob has bought the most, Daniela has bought the second most, and Candace has bought the least. Let's take a look at our last person, who is Maddie. By the way, all of these people were students in my class at one point, so be excited. You'll be in my future story problems at another date. So we know that Maddie has the amount that Jacob has, so I'm going to draw hers equal to Jacob, minus 7 ounces. Okay, so I'm going to draw this. I'm going to point out that this is 7 ounces. Cool? So she has the same amount as Jacob, minus 7 ounces. Ounces doesn't look like pounds, right? So we got to set up another proportion. Again, this problem has a lot of steps, but this is what a really complicated real-world story problem looks like. Okay, so now I have my proportion set up, right? I know 16 ounces in a pound, right? Because I'm trying to go to pounds, right? That's what my whole problem is about. And 16 ounces are in 1 pound. I know 7 ounces from my problem, right? Maddie has the same amount of Jacob, which we've determined is 8 22/100ths, minus 7 ounces, which we got the 7 ounces from our problem. So what I need to do, as we've gone over a lot, 16 times what equals 7. So I'm going to pull this aside and do it on the side. So I've asked myself, I've just written this out with algebra. 16 times something equals 7. Now, how do I get rid of this times something? Because 16 cannot be multiplied evenly into 7. So what I can do is 7, take my answer, divided by 16, and hard math problems, we get to use a calculator. The answer is 44/100ths. So that means that 7 ounces is equal to 0 44/100ths pounds. Always remember, I keep ounces with ounces and pounds with pounds. But I'm not done. Maddie has 8 22/100ths minus 7 ounces, which we now know is minus 0.44 pounds. Where did I get the minus from? It says less than in my equation, and that's why I wrote my numbers down the way I did. So I need to do 8.22 minus 0.44. Okay? Most important thing to do when adding and subtracting fractions is line it up, line it up.